Learners, today in this video we shall discuss operating systems important interview questions with a small discussion regarding the answer for a given question and the proper interview answer which we can give in our interview with proper English and proper technical terms. Okay, we shall immediately go for first question. Our first question is, what is a process and what role does the process table play? Okay, first we shall discuss the concept. Okay, now basically what is a process means. For example, I gone into Google Chrome and I typed some kind of mango here. Okay, so that I can experience some good mango images and see them. Okay, so going and typing and getting this mango page as an output is considered as a single process in operating systems. Okay. Now, there may be multiple processes in operating systems, and maybe they all might run concurrently. See, at the same time, I may do a Chrome search, or even I might download some kind of file. Okay, or even at the same time, I can play any funny YouTube video. So these all three processes can be concurrently done. Okay, so each and every single thing or task here is termed as a process with respect to OS. See, now what is process table means? See, there are multiple processes here. So there is a kind of stack process table where all the tasks that are being executed are stored in this process table, so that OS and computer will understand what tasks are being executed and or should be executed in further. Okay, now if you want to if you want a perfect definition for a process, you can define it as an instance of a program. Okay, now if someone asks me, hey sir, hey, what is a process and what does the process table play? So basically, a process is an instance of a program in execution. So for example, browsing some kind of browsing in web browser is a small process, or typing some commands in command prompt or shell is a kind of process. So the operating system manages the processes, and finally process table stores or keep tracks of the processes that are going on in the computer system, sir. Okay, once check it. Now then we shall go for our next question. Okay, simple dude. Okay, now our second question. What are the various states of processes? In our previous question, we discussed what is a process. So now processes, see, basically there are three kind of processes. Okay, now we shall discuss each of them. Okay, the first one is running. Okay, the first one is running. I think most of might you know ready, and the third one is waiting. See, for example, again we shall take our previous example. I browsed on Chrome Mango. Okay, so if I have correct internet and if I am on the web page, immediately I will be displayed some kind of mango images or some Wikipedia regarding mango. So here the process is running. Here I am getting the output process of mangoes. Second, ready. See, what is this ready means? See, for example, think I am playing. See, again take the same scenario, dude. I gone to Chrome and I browsed for mango. Now what happens suddenly is I want to play a YouTube video. See, YouTube recommended a funny video of my favorite YouTuber. So I go and I watch this. So what happened here is, see, when I'm searching for mango, this YouTube video is ready to play. Just if I click on it, immediately it will start playing. So all loading also completed. But now, as I am currently on the mango page, the process is not running. If I click on it, the process will run. So those kind of process are known as ready. Basically, you can consider all notifications examples like WhatsApp messages, or like that. See, third one is waiting. See, in waiting, what happens is, suppose think again, same example. I gone to Chrome and I browsed for mango, but suddenly what happened is I lost my internet due to some weather issues. I lost my internet. Okay, so if I lost internet, I cannot get the answer, right? So here the process is waiting for some kind of resource. Here the process is waiting for internet to come so that it can execute. As it does not have a resource termed as internet, it is not able to execute. So if I was asked in interview, hey, what are the different states of processes? So basically there are three states of processes: running, ready, and waiting. So in running, the process has all the resources required and has given permission by the operating system in order to execute. So second state is ready, where the process is prepared to execute in the queue of the OS. Sir, and the third is waiting, where the process cannot execute due to some kind of lack of resources, sir. So this is going to be my answer. Even you can give example if asked in order to for a better understanding. Okay, once check it. Okay, now okay. Define a thread and its significance in program execution. See, thread. See, these all are connected concepts, dude. See, we learned process is kind of task, right? Now, if, for example, we shall take one more process example. I have a Microsoft Word document. Okay, I want to edit this. We know editing this is some kind of process, but the thing is, I can do multiple internal tasks in this, right? See, in editing, I can change the style, I can edit or alter the words, I can change headings, I can even change footers, or even I can add images. So these all are internal processes. So a more quality technical term given for internal processes is a thread. So a thread is basically a lightweight process. Okay, it is the smallest. Like it's like an atom, dude. It's the smallest or lightweight thing in the process. Okay. Now, if I was asked, hey, define a thread and its significance in program execution. Sir, a thread, often referred as a lightweight process, is the smallest unit of process that can be scheduled by an operating system, sir. Sir, a thread represents a single sequence of executable instructions within a program. So, for example, MS Word uses multiple threads, like one thread to alter styles, one thread to alter words, one thread to alter headers, footers, and some other threads to alter images. So just a thread is kind of internal subdivided smallest processes. Okay. Once check it before we go for the next question. Okay. Now, next question. How is a process different from a thread? Okay, again these all questions are connected. See, process, thread, we studied in our previous three questions regarding these two concepts. itself. Now if he asks the difference, if you know the what is uh, the technical definition, process is kind of instance of a program, like editing a document on MS Word. What is a thread? A thread is just a, it is just lightweight process. Okay, it is just a lightweight process. Okay, now see here you said lightweight. Opposite, we can say it is heavy. Of course, process is a heavyweight thing, and of course this is lightweight, all of you know. And the third major difference which we have to notice that, see, in the previous example we shall go in threads. See here, styling, changing words, headings, footers, images are all related to a single resource of this MS Word document, right? See here, all threads share a single resource, right? You're observing, right? But look at processes. Here, if I am searching for mango, it is you, this mangoes, in order to give me images of mango, it is giving, I am using different resources from internet. Here, in order to edit this document, I am using a different document resource. So here the difference which we need to identify is process uses separate resources or addresses, whereas as in the previous example, threads uses common memory or resources or address spaces. So these three are the major differences. Even you can go for the example as we discussed. So if I was asked, hey, how is a process different from a thread? So basically a process is an instance of a program, whereas a thread is a unit of execution which is a light weight of a process. So a process is very heavyweight, it takes much time to execute, whereas a thread is lightweight and it takes very less time to execute. Sir, process shares different or separate address memory resources, whereas sir, threads share common memory or resources, sir. Okay, once check the answer. Okay, now we shall go for a next question. Okay, what are advantages of using multi-threaded programming? See, again this is an extension. See here, in this example we discussed, in the same document we are doing multiple tasks. The thing is we can do all these tasks at the same time, right? Correct. We can execute all these tasks at same time. So this particular thing in operating systems is only termed technically as multi-threaded programming, where multiple threads can execute a particular task at single instance of time by sharing resources. Here, simple. Here, as he asked advantages, we need to go with points. First point which you can say is improved responsiveness. See, what is improved responsiveness is, as the term suggests, responsiveness means the response which we get is very faster. Like at the same time, we can do multiple tasks, like we can download a particular resource at the same time, like we can download a particular file at the same time, and also at the same time we can do some kind of other task like playing some kind of song on Spotify. Okay, improved responsiveness. Second point is, as we previously discussed, threads share common single shared resource. The resources can be used efficiently. It is possible only because threads share common resource in between them. And the third thing is speed. As you all know, threads are very lightweight, so that the speed and efficiency of program can be increased. And the fourth thing is cost effectiveness. Okay. Now, if I was asking for you, hey, what are the advantages of using multi-threaded programming? So, uh, basically, some advantages of multi-threading programming are improved responsiveness, efficient resource utilization, enhanced concurrency and stability, uh, efficient and cost effectiveness, sir. Okay. So, once check it, we shall go for the next question then. Okay. What do you understand by the term thrashing in computing? So basically here he is asking what is thrashing. See, as the name suggests, what is thrashing? It is similar to some kind of crushing, destroying, moving, removing. So that is what thrashing is. But if we want to clearly understand what is thrashing, we have to understand the most important concept of OS, that is the concept of RAM or the concept of virtual memory. Okay, this is one of the most important concepts in OS. Okay, basically computer system is made up of two kinds of memories. Okay, we'll be often referring and hearing these two terms, RAM and ROM. Okay, RAM is basically primary memory and ROM is basically secondary memory. See, basically there is a primary memory RAM, which is generally of small size, but very fast and also very costly. Okay, primary memory. Okay, it can fit only some information, and there is second memory that is very big called as secondary memory. Will be generally these are referred as HDDs, SSDs, solid state drives. So these all come under secondary memory, or even called as ROM ROM. Okay, this consists of higher memory space. They are a bit slower but cheaper. Okay, basically all the information which we get is only from primary memory. So what happens here is that, see, primary memory for example has only 2 GB of space. Okay, now but here we want to store 512 GB or 514 GB instead. So what here happens is, okay, I cannot afford 514 GB of primary memory. So what I do is I will make 2 GB RAM plus 512 GB ROM. Okay, here we shall, so all the basics are over. Now we shall delve or move into actual concepts. Okay, actual concepts, what actually happens. Okay, this is primary memory RAM. Okay, now what happens here is this primary memory will have some kind of memory. Okay, it will have its memory divided in kind of contiguous blocks called as pages, which will store data. See, this data might be anything. Okay, this might be any MS Word document. Okay, or it might be any kind of YouTube video. The thing about RAM is it will store only required things or previously used things. Okay, but this secondary memory will store all things independent of required or not. It doesn't care about it. Okay, so what happens in this RAM is whenever a page or some kind of content is required and not found in the primary memory, that is RAM, from the secondary memory the content or data will be loaded into primary memory. From secondary memory data is been loaded into primary memory whenever there is requirement or whenever a fault is found. See, fault means if you not find a required page or content, what we do is we shift this least recently used thing into this and bring our required thing into our RAM so that we can access it very easily. See, for instance, we shall take a small example. So, in our previous example, we edited our MS Word document. So, this MS Word document will be stored in RAM. Okay. Now, I think most of you experienced this example too. See, when we try to load our old images, maybe in our system or phone or even drive, see, in order to hold old images it takes time because these images are stored in secondary memory, not in primary memory. So if the information should come from secondary memory to primary memory, this consumes a time. That is why we encounter that lag kind of issues. Okay, here this is the concept of RAM. Whenever a page or content is required in primary memory, it is being loaded into the RAM from the secondary memory. This all works on a simple concept of requirement. Okay, this is the concept of RAM. Just it runs only based on requirement. Okay, this is the concept of RAM. Okay, now we shall go for our answer. Now, as the name suggests, thrashing means what? You can call it kind of crashing or some kind of destroying. See, if in this RAM I am trying to search my old images, I am not able to find them. Okay, that means many times the data is getting shifted from secondary memory to primary memory, due to which I am experiencing a lag, which is also known as thrashing. Here the system performance get degraded due to many faults occur in primary memory as the content is not available there. Okay, so this is what thrashing is. Basically, it takes time to load from secondary to primary as data is not available in primary. So, hey, what do you understand by the term thrashing in computing? So, thrashing is a situation where the performance of a computer degrades or collapses. Thrashing occurs when a system spends more time in correcting page faults than executing transactions. Sir, as page fault increases, more transactions need to be proceeded from the paging device, thereby affecting or degrading the system performance, sir. Okay, now now check it. I think we can go for our next question. Okay, what is a buffer in computer system? See, buffer, this is one of the most important things where we shall go for a real life example itself. Now I think most of you watches YouTube videos every day, right? Now assume that I am playing a YouTube video. Okay, suppose I played until 5 minutes. Okay, now suddenly assume my internet connection is gone, but still until 7 minutes my video still gets played, right? I think most of you experience this thing. Though we lose our internet, our video will be playing for some time. Of course not until full, but at least until some time. The main reason for this is buffer. You know what buffer does? Buffer uh, priorly or before it stores the input output information. So basically what happens in buffer is, if we are sharing any file or we are playing any YouTube video from internet, it will basically store the information or data prior here. From this buffer, the data will be displayed on the screen. Okay, this is the reason why. So what happens is that until where the buffer stored the data, our YouTube video plays. If internet is gone and if buffer information is also completed, again we will experience the lag. Okay, it will be rotating in this manner. Okay, so this is what buffer, it basically manages input data transfer between input output. Okay, hey, what is a buffer in computer system? So a buffer is a memory area that stores data being transferred between two or more devices or two or more applications, sir. It's a very simple thing actually. Now we shall go for our next question. See, again, explain the concept of virtual memory. See, as I said for you in the previous question, the concept of RAM, same thing is also the concept here. See, I said you RAM, right? Basically, there is some kind of RAM which will store only required information, and whenever required, it will load from the primary memory, which is very slow. Okay. Now this particular process is known as virtual memory. See, you might all think, what is this term virtual here? See, the beauty is RAM space, you think it is only 2 GB, but the primary memory space is 512 GB. Okay. Though actually RAM can store or output only 2 GB of information, our memory, that is the information that can be stored, is not 2 GB, instead 514 GB. That means actually our memory is only 2 GB, but due to primary memory, our memory exponentially increased to 514 GB. Okay, that means memory actually doesn't exist, but it creates an illusion, or virtually it will create some kind of memory. That is what virtual memory. Okay, now, hey, what is virtual? Explain the concept of virtual memory and its purpose. So basically, virtual memory is a memory management technique that creates an illusion of a much larger main memory than our computer physically has. The idea of virtual memory is to use disk space in order to extend the potentiality of the RAM, sir. Okay, now we shall go for our next question. What is main purpose or function of operating system? See, this is one of the most basic question in operating system. See, what is an OS? What is OS means? Operating system acts as an intermediate between inputs and outputs. Okay, suppose we shall again go for an initial example. There is some kind of, okay, what did I draw? Extremely sorry, dude. Okay, now here I browsed some kind of mango in Chrome. Okay, my input is mango. Okay, now there is a thing called OS here. It will understand that this guy has want information regarding mango, and it will send to some kind of server, and this server will send information to us. And see, this all external thing is CN. Okay, keep that in mind, don't confuse, it is most important. OS manages internally, not externally. Externally is managed by CN, computer networks. Now it will take the input of mango. When the server returns the information to our computer, it will display the image of mango on the screen. This displaying of image is done by OS. It will manage the input and output. It acts as an intermediate between the computer applications or computer or user and the computer hardware. Okay, that is what OS is. And you know what OS does? All it does: process management, resource management, memory management, file management, all managing things, dude. That's it. No. Hey, what is main function of an operating system? Sir, an operating system acts as an intermediate between user of computer and the computer hardware, sir. The main purpose of operating system is to provide an environment in which a user can execute programs conveniently and efficiently. OS performs various tasks such as process management, resource management, memory management, and file management, sir. Okay. Now, we shall go for a discussion. What is mean by demand paging? See, again the same concept of RAM here. Basically, there is a RAM. Whenever required, it loads the memory. Okay, so basically, demand paging means this RAM internally divides into many contiguous or non-contiguous blocks. He will term each contiguous block as a page. So whenever a page is not found, it is been loaded from the secondary memory or ROM. Simple. That is what called demand paging. Whenever required, data or page is being loaded from secondary memory to primary memory. Hey, what is demand paging and memory management? So the process of loading the page into memory on demand or whenever required or when a fault occurs is known as demand paging. So demand paging is a memory management technique that optimizes RAM usage. Instead of loading entire program upfront, only the actively needed sections or pages are brought into RAM when required, sir. Simple. Okay. Whenever required, it will load. See, that's why I said the concept of RAM is very important. It's one of the main features of OS actually. Okay. See, again, define a kernel. See, kernel is something maybe not completely, but it is mostly same as OS, dude. Okay. See, this what this OS does is, see, OS is mostly connected to, see, of course, OS and kernel both act as intermediate between computer user software and computer hardware, but the actual thing is OS is mostly connected to the users. Okay, like it will play a major role in accepting inputs, or if I am typing some kind of things on keyboard, mouse movements, it will capture these all things. And kernel is of course an intermediate also, but it mostly manages hardware related things, uh, uh, like for example memory management. Suppose in our previous example, if we were editing an MS Word document, so this memory management is done by kernel, whereas showing the particular output for us, that is UI, or accepting the words that have to be changed from the user are managed by OS. So memory management, process management, so these kind of things are done by kernel. It is mostly towards hardware side. Okay. Now, hey, define a kernel and explain its role in an operating system. So, a kernel is a core component of an operating system that manages system resources and facilitates communication between hardware and software, sir. It acts as a bridge between software applications and computer hardware, sir. It manages tasks such as memory management, process management, and resource management, sir. Okay. This is the answer. Right. Simple, dude. Simple. Once check it. Okay. Now, What are the various scheduling algorithms? Again, this is one of the most important questions. See, basically, what is this? What are the scheduling algorithms? This, as the name suggests, it will schedule. Okay. Now I am going to take three things here. Okay. Three tasks I want to perform. Okay. First one is download 2 GB game. Okay, this downloading 2 GB game could take me around 1 hour as my internet is very slow. Second is chatting. Of course, you may chat with anyone, dude. Of course, chatting, or even you can say, or even you can call it sending or messaging. Okay, this takes very much less time, right? Maybe a second, Thor internet is slow. And the third task which I want to perform is some kind of play YouTube video. Okay, to load, even though it low clarity, it could take around maybe not 10, take for instance 5 seconds. So these are the three tasks which I need to schedule. Okay, now what our scheduling algorithms are, it schedules these three tasks in which order they need to be performed. Okay, basically there are four scheduling algorithms. Okay, first one is FCFS. Okay, visual, first come first serve. As the name suggests, first come first serve. What this does is, first it will, instead of we shall use a number here, it will download my whole game. That means 1 hour it takes. Second it will send the chat message which would take 1 second. So the thing here is, see, suppose if I started suppose think at the same time I started downloading the particular file, and at 9:01 I messaged my friend. So the beauty of this FCFS is that some call it as a flaw. I think it's a flaw. This particular message delivering starts at 10, not 9:01, because according to FCFS, it completely executes a particular task. It completely executes this downloading a game, then it will chat or send the message independent of its execution time. Third is it will play the YouTube video. So finally I should wait 1 hour for this YouTube video. So this is what FCFS is. Okay, now second is SJF, shortest job first. See, we understood the main problem in FCFS is, see, this particular first task is taking 1 hour. Why don't I execute first second chatting task? As it completely it can be completely done in just a second. And second, I will be going to play this YouTube video that will be complete in 5 seconds. Then I will be downloading my required thing. But still, dude, really, do you think is this some kind of correct thing? Really? No. There came a brilliant genius called Robin. I don't know Robin is his name or his friend name, but the technique is round robin. See, as the name suggests, round. So what happens? See, in FCFS and SJF, what happen is, see, if I have three tasks, if one task completely executes, then only I can go to second or third task. Okay, but this Robin observed the main flaw in it, and what he did is, he said, see, I will give a constant k time for each task to execute. Like I will give a 0.5 second to execute for each and every task. If it completes it in that time, fell and good. If it not completes, again after executing all tasks, I will be executing that. Okay. Now, according to round robin, what happens is, first, for 0.5 second, our game downloads. In the next 0.5 second, my chatting. Next, in the 0.5 second, my YouTube video. Next, in the 0.5 second, my game downloading. In the next 0.5 second, my chat will be delivered, and next in the 0.5 second, my YouTube video will be played. So look, this is a very perfect technique where all my three tasks can be concurrently done at the same time. Okay, here the main thing is a constant time is given for each and every task. And the fourth technique, see, think, dude, can there be any technique still better than round robin? The straightforward answer, as you all are expecting, of course, is no. Okay. But what is this fourth thing, if you ask me? It is called priority scheduling. See, what is this priority scheduling? You see, there is a small edge case. Okay, there is a very much important edge case here. Suppose think, I want to execute these three tasks and I gave input for my system. Suppose think our most efficient round robin is executing it, but the main problem here is internet has gone. Okay, if internet has gone, our fourth task should be display an error. Okay, display an error. So what happens in this FCFS, SJF and round robin is, though my internet is gone, this error message will not be displayed for me consistently. Instead, all these tasks will be trying to get executed, which cannot happen, which is waste of time and waste of power in OS. So that is why priority scheduling assigns a priority to each and every task. Okay. Now what this priority scheduling does is, my fourth task is internet issue. Now if my internet is not there, until and unless I will not relieve my internet issue, it will be giving the same error message, internet issue. Then when I resolve this particular highly prioritized internet issue, then I can execute my tasks based on my required priority. So these are the four algorithms: first come first serve, shortest job first, round robin, and priority scheduling. Now if I was asked, hey, what are various scheduling algorithms used in operating systems? So basically there are four scheduling algorithms in OS that are usually used to allocate CPU time for each and every process in the memory. So the first technique or the first scheduling algorithm is FCFS, first comes first serve, where the processes are executed in the order in which they arrive in the queue. So the second technique is shortest job first, where the process with the shortest execution time is executed first. And the third technique is round robin, sir, where each process will be executed in a fixed time, though completed or not. But in a form of cycle, each and every process can be successfully executed. The fourth scheduling algorithm is priority scheduling, where each process is assigned a priority and the process with the highest priority will be executed first compared to others, sir. Okay, now check it. Okay, check it. Now we shall go for our next question. Okay, what is primary goal of multiple programming? We discussed this question in the processes answer, where multiple processes are executed at the same time. Even in the previous example, we executed 4 tasks or 3 tasks at the same time. Okay, so this is what multi-programming is. A CPU can execute multiple programs or processes at same time. Okay, see, that is the primary goal. what happens is that increased utilization. See, memory can be efficiently used, and even improved efficiency. Okay, that means the speed instead, you can call this as. Okay, and third one is concurrency. Like many programs or process can be concurrently executed. Okay. Hey, what is the primary goal of multi-programming? So the primary objective of multi-programming is to maximize the utilization of CPU and improve the overall efficiency of the program. So the main advantages of multi-programming are increased memory utilization, improved efficiency and speed of processes, and concurrency where multiple processes can execute at the same time concurrently. So, okay, once check it. Okay, once check it. Okay. Now, what is a time sharing system and how does it work? See, see, as the name suggests, time sharing means someone will share time. It is a very beautiful concept. How can we share time? Okay. OS does this. OS does this. Okay. Now see, take example of Amazon website. Okay. See here, in 1 second, around 10 crore people try to order a single item or try to order multiple items in the same Amazon website. Like for example, think as there is an offer on iPhone 14, many users try to order this at the same time, right? So but here you might get doubt. So if these many users order at same time, suppose think that there are only 1,000 pieces of iPhone 14, but if 10 crore people want to order that, how can operating system understand that only there are 1,000 pieces, but if there are any requests after 1,000, it have to stop. It should not process. It should show item is been sold out. Or even you can observe this in the case of booking movie tickets, where multiple users try to book tickets at the same seat. So what happens is, OS basically very fastly, it will switch between each and every device. This switching time is very short, so that we cannot understand that it is switching. Okay, it is switching so fast so that it will make system accessible for each and every user with managing requirements. Okay, simple. Basically it will make multiple users to interact a single application on a single application at same time. Simple. Okay, hey, what is a time sharing system and how does it work? So a time sharing system is a type of operating system that allows multiple users to interact with the computer simultaneously. It achieves this by rapidly switching the CPU among users very faster. This is the answer. Okay, once check it. Okay, now I think we can go for the next question, and I think this is the last question. Yes, this is the last question. Okay, what issues arise in computer system that operates without an OS? Okay, simply you can all say advantages of OS here. Okay, simple dude. I will say small tech. See, concept here for, see, if OS is not there, if I give any input, computer will take the input, okay, but it will not understand what and how to give output. Suppose if I open some kind of os dot file dot py, os file dot py, see, I will be clicking on this, but something else will be opened. Okay, some kind of oops might get opened. Okay, that is the main use of operating system. It will manage the user's inputs, outputs, software and hardware. Okay, so now basically if anyone asks you what happens without an OS, or if you forget an answer of, or if you don't get any idea, simple dude, what you do in interview is simple. Remember only one word: management. All know what will OS do, it will manage. Now for this manage, you add many words. See, first question ours is process management. So process management cannot be done with OS. Okay, set completed. Next is resource management. As we discussed in the previous example, if I open something, some other thing will be only opened. Third one is memory management. Of course, all of you know that how virtual memory affects in order to improve efficiency. So that cannot be happened. And the next one is file management. Okay, it is similar to resource management itself. So can other, yeah. So one more management, device management. See, what is device management is, uh, see, now I will connect my computer system to an external mouse, to an external keyboard, to an external speakers. For instance, you take it, please adjust with the diagrams. So computer needs to understand what inputs and outputs are given from these devices. So now from mouse I can accept only moves, right? Moving left, right, top, bottom. But I cannot accept words like L, R, O, S. Mouse will not give these inputs, whereas keyboard gives this word inputs. Okay, computer should understand that. And in output, see, for speakers, see, you know that speakers cannot print. Okay, so print output should not be given for printer. Instead, sound should be given for the speaker. So this is what OS manages. So what issues arises in a computer system that operates without an OS? So OS is one of the key component of computer. If it doesn't exist, uh, uh, process management cannot be done, resource management, memory management, file management and device management also cannot be done, sir. And it also affects security of the system, sir. Okay, now, so these are the answers. We shall discuss other questions in the next video, and these are most majorly asked questions. We shall discuss the next priority questions in the next video. Kind of priority scheduling, right? Thank you, learners.